Today we are going to look into a new topic. It is calculation of average depth of precipitation over a catchment area. For this, basically we have three methods. First one is arithmetic method. Second one is catchment polygon method. The third method is isohethal method. Third method is isohethal method. So we are going to look each and every method into a deep. So first method is a very simple, which is a arithmetic mean method. So here we have the rain gauges located at various locations across the area. This is our area. We have different rain gauges situated, and simply what we do for taking calculation, suppose this is 1 2 3 4 5 6 7 8, we simply take the readings like p1 p2 till pn and divide it by the number of rain gauge stations, and we get the average rainfall. So key points about this method is like this is the least accurate method available to calculate the average precipitation over a area. Then as it is least accurate, so we are having different methods to calculate the average precipitation. So this next method comes, and it is known as catchment polygon method. So in this method we have a area like this. So basically the main motive of this method is that we give representative area for each rain gauge. So how we do it? Like we have rain gauges situated at various locations. So what we do? Basically we join all the rain gauge stations available by a triangulation technique. When all the available rain gauge stations in an area are joined, they form a triangular figures. So what we do, we draw perpendicular bisectors from the lines joining the stations, like this 1 2 3 4 5 6 stations. So what we do, we draw perpendicular bisectors on this, like this. On each and every line we draw this perpendicular bisectors. So this perpendicular bisectors from the catchment polygon. So likely we get area something like this. So the area which I have shaded with the green color is area contributing to the rain gauge station number 3, and the rest of the areas, like for A, I will show it with a different color. For A, this area will be considered for the A, and similarly for all other areas the precipitations will be considered. So here we are considering the weighted average of a rainfall. So for all these these areas are calculated by planimeter. So we have areas and we have precipitation of there. So to get the precipitation average depth of average precipitation, what we do, precipitation into the area plus precipitation of the next session into the respective area of that session till the Pn and An number of the, and it is divided by the total area of that particular catchment. So we will get average depth of precipitation by summation of Pi Ai, where I represents for the number of rain gauges from I is equal to 1 to n, and then we have summation of all the areas which is from I is equal to 1 to n. So this is a very simple method in which we give weightage to the rain gauge stations, and this weightage depends upon the area contributing to the particular rain gauge station and the total area of the catchment. These are once calculated, then repeatedly we can calculate the average depth of precipitation over that catchment. So what is specific about this method? This is used only for plain areas. As why it is used for only plain areas? It is used only for plain areas because it does not take into consideration the elevations. So elevation of that particular area is not taken into consideration, so it is suitable and most effective for only plain areas. So as it is not calculating the mean precipitations from the topographic point of view, so here comes the our third and last method. It is isohethal method. So first of all, what are isoheights? So isoheights are the line joining points of equal rainfall. So, and this method is known as most accurate method available, and it also take into consideration the topographic influence. So this is the important point to note and to remember, that this method takes into consideration the topographic influence. Then how it is calculated? So like we have a area, so from the rain gauges we draw isoheights, like this is isoheight number 1, this is isoheight number 2, this is isoheight number 3. Then we calculate the areas in between the isoheights, like A1, A2, A3, A4. So how we calculate the mean precipitation? So mean precipitation is calculated by summation of Pij into Aij upon the area of a catchment. So here main consideration is Pij. What is Pij? Pij is like isoheight number 1 plus isoheight number 2 precipitation divided by 2. Basically it is the average precipitation. So like precipitation means rain gauge value of isoheight 1 plus rain gauge value of isoheight 2 divided by 2 is Pij. So it is very simple and it is most accurate. Now if we want to compare the three methods, so how they are progressing. So basically the first method, which is arithmetic mean method, so it is simple method, not taking into consideration the representative area, not taking into consideration the topography. So when we take into consideration the area, representative area, then we come to the method known as Thiessen polygon method. And when we consider topographic influence, then the third method is known as isohethal method. So these are the key points. This one is the most accurate method. This is the least accurate method. So these are the main points to remember here. Thank you.